Hi, everybody. Matt Yonkovit, Head of Open Source Strategy at Percona, or the HOSS for short. I'm here with another podcast, the HOSS Talks FOSS, and today I'm here with David Zhao from ZettaDB. Hello, David.
Hi, Matt. Hi, everyone. Glad to meet you.
It's very glad to have you here. Now, David, can you tell us a little bit about your background? You actually worked for Oracle and for Tencent.
Yeah, I worked in Oracle for like 6 years or so, and in Tencent for another 3 years. So in Oracle I worked on Berkeley DB and MySQL database systems, and in Tencent I worked on TD-SQL. It's a distributed DBMS. That's basically what I did. In my entire career, I worked on database systems, and
And the internals, though, not just the databases. You were into the very low levels.
yes, yes. Starting from the Berkeley DB, it's embeddable database engine, storage engine, and it supports all the transactional semantics, the SID properties of transactions, and although it's a key value, it has a simple key value interface. In MySQL, I worked in the optimizer team, worked on several functionalities of the optimizer of MySQL. Yeah.
And you like performance because in your talk you compared quite a bit of different performance benchmarks. So I can see the optimizer team was a good fit for you early on in your career.
Yeah, it's a great team.
Yeah.
So great engineers in the MySQL optimizer team.
Yes.
Yeah.
And everybody always wants faster. They always do.
Yeah.
So you decided to leave Tencent and start ZettaDB.
Yeah.
And so now you have a project called Kunlun. Yes.
Kunlun. Yeah.
Kunlun.
Yeah.
Okay. Which you talked about at Percona Live. Now, one of the cool things, the nice things about the talk I listened to the talk, is you do compare Postgres and MySQL at a kernel level.
Mm-hmm.
So you walk through the different features.
Yeah.
And it sounds like you really approached your project by trying to take the best that was in Postgres and the best that was in MySQL and combine the two.
Yeah, exactly. Because I also worked on Postgres for several years in Teradata, and I know how it works. I know its strengths and weakness. So basically, in the Kunlun project, what I want to do is to combine the best of both Postgres and MySQL. And I believe the essence, the best part of Postgres is the query processing, and for MySQL it's the InnoDB storage engine and its binlog replication. Although it has also very good optimizer, yes, for sure. But anyway, I believe if I combine the two, I can build something new. That's the Kunlun distributed DBMS. Now we are very close to making it a commercial database system. It has all the basic functionality, including the transaction processing, the query processing, the common DDL and DML statements are all supported now. So, and it shows very good performance, and also other aspects, for example, stability, crash safety, and so on.
Okay. And you built this as a sharded system, correct? So the data is share nothing as opposed to share everything.
Exactly. The reason is that in future, especially in big countries like in China and USA, there are a lot of internet users. There are many companies which have a huge amount of data. That's hundreds of terabytes of data. For example, I worked in Tencent before. The DBMS we built, it was called TD-SQL. It's a distributed DBMS which uses MySQL as the storage nodes. It supports a lot of internet businesses and games of Tencent, and each of the, for example, the games, there are a lot of data. So I see there will be many other companies which will have more data, similar amount of data as Tencent or Alibaba and so on, because these are very world-leading companies, internet companies of the world. So, but there will be more companies which will also meet all these challenges. That's why I left Tencent and built this project, and I believe it will help a lot more smaller companies which don't have the resources to build a special database kernel team to do all this kernel development. So
yes, and a lot of the work that you're doing is similar to other problems that other database or other companies have had. YouTube, for instance, created VTES, to do their specific sharding solution. I know that at the Percona Live there was also a talk from the people at Uber who built their own database engine on MySQL. You've taken the unique approach, like I said, of combining the best of both worlds with Postgres and MySQL, whereas those two are very focused solely on MySQL. So this is a very common problem, and it's a very unique solution that you've taken to it. Now, I'm curious, one of the challenges with any of these systems is always, like I mentioned, the sharding. When you set up your tables and your structures, are you picking the shard key, or is the shard key automatic? Tell us a little bit about the sharding implementation.
Okay, the sharding part. Okay, in Kunlun we need the DBA to choose the sharding key for each table. So
Okay.
that means a little bit extra work for DBAs. But for a good DBA, he needs to know his business, what kind of tables he's building. So that makes sense for him to know that each table should be sharded or not. For example, a huge table like orders table, it should be sharded because there can be millions or billions of orders. For another table, for example, a department table, it's small, so it should not be sharded at all. It should be a standalone table. So and for each for different types of table, he needs to specify how the table should be sharded. For example, it should be hashed by some columns that he chooses, or another table maybe should be sharded by range, for example, by date. For example, other table may be sharded every week. Every week there should be or even every day for big websites like Taobao. So it makes sense for DBA to know all these details. So our approach, our philosophy is that DBA should know this and should get involved in all this work. It should not be something that's just like a simple camera. I don't know how to say that in English. Anyway, it's that all this extra work DBA does makes our system more be able to do more optimization. For example, we know how each table is sharded, and we can do more optimization, performance optimization. So it's a balance. We choose the professional end. It's actually not a lot of work. Actually, it's only a little bit extra work, and we can make a DBA life easier by providing a GUI interface. So in the end, they don't have extra much work to do.
Okay, great. And I mean with this with Kunlun, you have a system that is distributed, and performance on big data is always important, but sometimes systems struggle with smaller queries or maybe aggregates, or maybe there's certain query patterns that don't work well with particular implementations. Are there some implementations or some query patterns that work really, really well in Kunlun right now, and other ones that still need some work?
I think queries generally work very well in Kunlun. Things like aggregates is what we are working on now.
Okay.
It's easy to the entire in one word the guideline is to push down extra work, push down as much work as we can to the storage shards, so that we can do parallel and distributed work. They can work together at the same time. So, and we can minimize the amount of data transferred. So that's the simple one-word philosophy. So maybe for a distributed system, maybe the network latency is something that you just can't totally avoid. But the good thing is that the computing nodes are always supposed to stay in the same, at least data center with the storage shards. Users in real deployments seldom separate them across multiple data centers. They can separate some part of each storage shard, some node, one or two nodes to another data center for crash safety, for high availability. But they always they should put the computing nodes together with the majority of the storage shards.
Yeah, it's always hard to have that geo-distributed cluster because you don't know the network connectivity and the volatility between two separate geo-located data centers. I know, like, going from, let's say, China to a data center in Europe might have latency issues that introduce all kinds of complexities and issues that you just might not normally have to deal with. So it is a complex problem, definitely.
Yeah.
Now, Kunlun is 100% open source, right? So it's available on GitHub?
Yeah, it's open source Kunlun is open source in GitHub, and we actually also have an enterprise edition. The enterprise edition has exactly the same set of functionality as the open source edition. The only difference is the performance. Actually, the enterprise edition has some particular performance enhancements.
Okay. And so you're following the model that, hey, get started with the free version, and when you need more performance, call us up, and then we'll talk about buying the license or the support for the enterprise version.
Yes. And also the open source edition has all the crash safety fixes to MySQL. I mean, I wrote some article, maybe you already know. The MySQL has quite some crash safety issues regarding the XA transaction. We fixed that, and that part are all open source. So the open source edition is actually crash safe.
Well, that's good. I actually know that way back because I worked for MySQL AB, right? So way back. Back then, XA transactions were added on as almost an afterthought. So there wasn't a lot of work, and we always would tell people from a consulting perspective, we don't know if you really want to use those because they haven't been as tested and as ready for production as people might like. So we back then we used to tell people that. So it's great that you fixed some of those issues because I knew that some of them existed since 2007 probably when I was involved.
Actually, I think maybe the TD SQL of Tencent, that's the project I was working on. My responsibility was to make TD SQL a real distributed database in Tencent.
Okay.
Tencent, the TD SQL is maybe probably the first distributed DBMS that uses MySQL as storage nodes that totally fix all the MySQL XA issues. That's why I'm proud that I make a lot of contribution to the MySQL team. We contributed all the bug fixes, reported all the bugs we found regarding the XA transaction to MySQL team, and some of them have been fixed. Some have not yet in MySQL 8. So that's why I still need to fix. We still need to fix several XA issues, XA transaction crash safety issues in Kunlun storage. That's our MySQL branch derived from.
So what I could do here is, while we're on here, I'll call out Lenz Grimmer, who is in charge of our server engineering. Lenz, you should talk to David and get those patches and put them in Percona server.
Yeah, sure. I'm glad to contribute to the patches to Percona and MySQL teams.
Yeah. Oh, it's great. And that's the power of open source, right? Is people have different use cases, they find issues, they can fix them, and that's really a great thing.
Yeah.
Well, David, thank you for coming. Thank you for talking at Percona Live. If you haven't seen David's talk at Percona Live, it is available now, either on our website or through YouTube. It is 100% free. I would definitely encourage you, if you want to know the differences between Postgres and MySQL at a kernel level, to check it out. It is a very interesting talk from that perspective. And good luck with the project, and hopefully this helps get people interested, and they'll try it out and give you feedback.
Yes, thank you very much.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.